Hi, welcome to the last video of this section, Generating CAPTCHA Images. In the previous video we learned how to plot data on a map using Basemap Toolkit in Python. In this video you'll learn how to harness Python's imaging library to generate images, render lines and points, and also render text. So here we'll first define image size, text, font size, background color, and capture length. Then we'll add some noise in the form of lines and arcs. And then we'll return the image to the caller together with the capture challenge. So, let's do it. Although this is not strictly data visualization in usual terms, the ability to generate images using Python comes in handy in many cases, and this is one of them. Before we move ahead, let's recall what capture images are. CAPTCHA stands for Completely Automated Public Turing Test to Tell Computers and Humans Apart, and is trademarked by the Carnegie Mellon University. This test is used to challenge computer programs that automatically fill various web forms that are primarily targeted at humans and that should not be automated. Usual examples are sign-up forms, login forms, surveys, and similar. CAPTCHA itself can take various forms, but the most common form consists of a challenge where a human should read an image with distorted characters and numbers, and type in the result in the related response field. We'll show you what is involved in creating a personal and simple capture generator by performing the following few steps. So we first define size, text, font size, background color, and capture length, as you can see here. We then pick random characters from the English alphabet and draw those image using our defined font and colors. Next, we add here some noise in the form of lines and arcs. After this, we return the image object to the caller together with the capture challenge. And finally, show the generated image to the user. Let's now dive into the workings of this code. So, this example shows a process for using Python's imaging library to generate predefined images, to create a simple yet effective capture generator. We wrapped the functionality into one class, Simple Capture, because it gives us a safe place for future development. We also created a custom simple capture exception to accommodate further exception hierarchies. Let's now start reading from the main section. At the end of the code listing, we instantiate class-giving settings of our future image as arguments to the constructor. Following that, we call the getCapture method on the SC object. Here, getCapture shows the image object as a result, but we also return the image object to the potential caller of this method, so it could make use of the result. The usage can vary. The caller could either save the image on the file, or if this was a web application, return the image stream and written challenge to the client requesting this capture. The important thing to note is that in order to finish the challenge response process of the capture test, we must return the capture string generated on the image as text so that the caller can compare the user's response with the expected values. The getCapture method first verifies the input arguments in order to override the class defaults if the user provides custom values. After that, a new image object is instantiated by image.new. This object is saved in self.image, where we use it to draw and write text. Having written the text to the image, we then add the noise of randomly generated points and lines, as well as some arc segments. These tasks are carried out by the addNoisePoints and addNoiseLines methods. The first one loops a few times and adds a point of random location on the image, not too close to the edges of the image, and the latter one draws lines from the left-hand side of the image to the right-hand side of the image. We constructed this class using some assumptions about its use. We assume that the user will just want to accept our default settings, that is, a random 7 characters on a random background color, and receive the results from it. This is the reasoning behind placing helper functions in the constructor to set random text and random background color. If the most frequent and effective usage is always to override configuration, then we want to remove these operations from the constructor and place them in separate calls. For example, maybe a user wants to always use English words as the capture challenge. If this is the case, we want to be able to just call a method to provide us with the results like that. This method could be getEnglishCapture, and with the random logic of this constructor, we would then construct that method to pick random words from the provided English dictionary. On a Unix system, there is a common English dictionary inside the dictionary/words directory that we could use for this purpose. Here is an example of the lines of code to be able to use English language in the CAPTCHA you implement. Overall, the example of the CAPTCHA generation is not production quality and should not be used without adding more protection and randomness, such as letter rotation. If you need to protect your web forms from bots, there are already third-party modules and libraries that you could use. There are even specialized modules built for the existing web frameworks. There are event web services such as reCAPTCHA, which you can find at Google's site, with an already proven Python module, reCAPTCHA client, that you can sign up and use here. It does not require any imaging libraries because the image is pulled directly from the reCAPTCHA web service, but it has other dependencies such as pycrypto. Using this web service and library, you're also helping books be scanned using optical character recognition, i.e. OCR, from the Google Books project or old editions of the New York Times. You can even read more about it on this reCAPTCHA website. Let's now run this file and check the output. So you can see the capture image we generated with this code. Superb. In this section we started plotting with images. We then displayed images with other plots in figure, and then plotted data on a map using the Basecamp toolkit. And at the end we saw how to generate capture images. In the next section we'll explore the use of right plots to understand data.